Okay, on this problem, it says a psychology experiment sometimes involved testing the ability of rats to navigate mazes. The mazes were classified according to difficulty, as measured by the mean length of time it takes rats to find the food at the end. One researcher needs a maze that will take rats an average of about 1 minute to solve. He tests one maze on several rats, collecting the data shown on the right, completes parts A through D. Now, we did not go over how to create a normal probability plot. It is in your book. It's quite sophisticated. You can do some research online if you want, but in order for us to continue this problem, let me just tell you that a normal probability plot compares the z-scores of the times to what they should be if you had a normal distribution. And if you get a straight line that or appears to be a straight line increasing, then you can say that you probably have what nearly normal data. So it has to be choice A to be correct. So just pick the one that has an increasing straight line and you'll be good to go. You can read more about that on your own if you want. Now I'm going to copy this data into a table. So I'm just going to copy it into the table. I'm going to come into my one sample T and I'm going to paste it in here. And then I'm going to have it calculate. I'm going to have my computer calculate the mean and the standard deviation for me. And so I'll just go in here on the data and do equals the average. And then I'll grab the data. And then the standard deviation, so equals standard deviation. And I'll grab the data. Okay, and these are the numbers I'm going to put in for the sample mean and sample standard deviation. So right up here I can just do equals and put this one and hit enter. And in this one I'll just put equals in that one and hit enter. And I can see that there are 18 data values, so I could just type in 18, or you can actually write a program, a formula for it to count. Okay, let's go back to the problem. It says, test the hypothesis that the mean completion time for this maze is 60 seconds. Assume alpha equals 0.05. All right, so it either is or it is not 60 seconds. So the null will always be the equal to, and then we just want to know whether it is 60 seconds or not. So there's no greater than or less than. All right, calculating the t statistic, I had to come in here and I put 60 in for my null. And my t value is this, negative 0.8768, negative 0.877, I think rounded to 3 decimal places, or rounded to 2 decimal places is negative 0.88. Okay, and then the p-value for the not equal to, I'll come in and I'll see the p-value is this number right here, 0.3927, and they want it, how do they want it rounded? To 3 decimal places, so 0.393. Okay, now that's a very large p-value. Even at a significance level of 0.05, you're going to fail to reject the null hypothesis. There's a lot of evidence. You can assume that this data came from a place where the null hypothesis is true, where the mean value is 60. So I will fail to reject the null. There is sufficient, the mean is, but it is, there is not sufficient evidence to suggest that the mean time required for the rest is not 60 seconds. It's actually this one. No English teacher would like that sentence, but we don't have evidence to suggest a difference from the null. Eliminate the outlier and test the hypothesis again. All right, so let's see if we have an outlier here. It would have to be this 93.8. So I'm just going to come in here and just hit the space bar. So I have a new mean and a new standard deviation, but my sample size reduced to 7. And so my t statistic is a negative 2.57. And then my p-value is 0.020. And then I still am going to fail to reject, or actually this is a very small p-value, so I will reject the null hypothesis. There is sufficient evidence because I have a small value, it's smaller than 0.05. Okay, and I don't have much time. There is, in this case, there is sufficient evidence to suggest that it does not meet the